In this video, we'll learn the differentiation by the first principles. Now, differentiation is the process of finding the derivative, or the rate of change of a function. Now, let's say we had this weird looking polynomial. Let's draw that again. Looks like that. No. So that's point P, and that is point Q. Now, if we draw a chord connecting point P and Q and find the gradient, we will be finding the average rate of change. Now, in this video, we'll be focusing on the instantaneous rate of change. Let's say the instantaneous rate of change at point P. So we're trying to find the gradient of this tangent. Now, we know that as we move Q closer to P, our gradient will get closer to the gradient of the tangent line at P. So if we keep moving this point towards P, at one point it will become the gradient of the tangent that touches P. Okay. Now, previously we could only estimate the gradient, but now we can actually find the exact value of the gradient. But first we need to find a generalized model. So let's say we had a similar looking graph. So we need a page. A similar looking graph that looks like this. Let's say we have point P here. Let's say we had point Q here. Now, if this point is x, so the x coordinate is x, and let's say that function is fx, we don't know what it is, but we know that it's function x, then the y coordinate of point P would be fx, right? Because we just substitute x into the function. Now, for the x coordinate of Q, we can write that as x plus h. So now that x coordinate will be here. And obviously the distance between x and x plus h is h. That's what we're changing the x coordinate by. Okay, so obviously the y coordinate would then be f x plus h. Then we find the gradient of the chord connecting P and Q. So gradient is y2 minus y1 over x2 minus x1. If that's x2 and that's y2, and if that's x1 and y1, then our gradient would be f x plus h minus f of x, and then x plus h minus x. So our gradient would be f x plus h minus f of x over h, because the x's cancel out. Now, this will find the AROC, or the average rate of change. Now we want the instantaneous rate of change. And to find the instantaneous rate of change, we want h to equal 0. Because that's when the point Q and P overlap each other. And then we'll be able to find the gradient of the tangent. So maybe the tangent may look like this, I guess. I don't know. Something here. That. Okay, so we want h to equal 0. Now this is where we add something called limits. We write lim h approaches 0. Now a limit is a value that something approaches, and in this case we want h to approach 0 because we want to find the tangent, which is the instantaneous rate of change. So our final gradient, or the generalized formula, that's yellow, is m equals limit when h is approaching 0, f x plus h minus f of x over h. Now, you realize that if h is approaching 0, then that means the denominator will be 0. But we can't divide by 0. So what we'll have to do is we'll have to cancel h out with the numerator, and we'll go through that in a sec. Let's say we had point P at 1, 1. Let's say point P. Oh, that's so wrong. Okay, this way. That's 1, 1. And we want to find the instantaneous rate of change at the point x equals 1, or 0.11. Now to do that, we set a point Q. And let's say that's 1 plus h. So if that's P and it's Q, this distance here is h. And then the function, then f bracket 1 plus h. That just means we substitute x equals 1 plus h into the function. And our function, fx, is equal to x squared. So our graph will go further like this. Okay, now let's use the formula we developed before. Well, maybe not the formula, we can just do it from here. So the gradient of the chord connecting PQ is f of 1 plus h minus f of x, but we know that f of x is 1, and h. Okay. So now we just need to calculate f1 plus h. So f1 plus h is 1 plus h squared. That's 1 squared plus 2h plus h squared minus 1 over h. Now the 1's cancel out. And now you see here how you can group the numerator to h plus 2. So the h's can cancel out, and we're left with h plus 2. Now that's the average rate of velocity between P and Q. Now we want to find the instantaneous rate of change at P. So what we do is we put a limit where h approaches 0. Now if h is approaching 0, it will eventually be equal to 0. So we substitute h equals 0, and we get 0 plus 2, which is 2. So we can say that the instantaneous rate of change at point P is 2. Let's try another example. Let's say we had the function fx equals x cubed. Okay, and let's say our point is 2, 1. The question might say, find the instantaneous rate of change at the point 2, 1. Now we'll use the formula this time. So the formula was f of x plus h minus f of x over h. In this case, 2 is our x and 1 is our y. Well, we don't need a y, but it doesn't matter. So we have function 2 plus h minus f2 over h. Now f2 is 1, shown here. That's equal to 1. We just need to calculate f2 plus h. Now 2 plus h cubed, use your Pascal's triangle. It should be 2 cubed plus 3 times 2 squared h plus 3 times 2h squared plus h to the cube, h cubed. So that will be 8 plus 4, 12h plus 6, 6h squared plus h to 3. Oh wait, sorry, f2 is 8, it's not 1. My bad. So it's 2, 8. Okay, so we have that in the numerator, and we have 8. Okay, so it becomes 8 plus 12h plus 6h squared plus h cubed minus 8 over h. The 8's cancel out, and we get 12h plus 6h squared plus h cubed over h. We can divide by h. So we're left with 12 plus 6h plus h squared. And I forgot to write the limits, but you need to write the limits here. And here, and here, and here, and so on. So it says the h value is approaching 0. So we can just say that h equals 0. Anything times by 0 is 0. So our final answer is 12. And we can say that our average rate of velocity, our instantaneous rate of velocity, instantaneous rate of change is 12 at the point 28. Now we'll move on to finding the derivative of a function. Now to find the derivative, we use the exact same methods we did before. We used a formula and we simplify. So the derivative is a function that allows you to find the gradient at any given point in the original function. So in the original fx function. Okay. Now let's try, I'll explain more through an example. Question says, find the gradient of the secant PQ and hence find the derivative of fx equals x squared plus x. So our function looks somewhat like this. Okay, and let's say our point P is here. That's Q. So that point would be x comma x squared plus x, because that's the y value. We just substitute y into the equation, x equals x into the equation, and so we obviously get x squared plus x. This point would be x plus h. So we substitute x plus h into x, and we get x plus h squared plus x plus h. And now we find the gradient of the secant PQ. This thing. So m equals y2 minus y1, so x plus h squared plus x plus h, minus x squared plus x, and then h. Okay. Now this is called the first principles. So the formula fx plus h minus fx over h, where y is approaching 0. That is the formula for the first principles. Now we should put limits here. So lim h approaching 0. So x plus h squared is x squared plus 2xh plus h squared plus x minus x squared minus x over h. Limit h approaching 0. Now x squared and negative x squared cancels out. X and negative x cancels out. And so we get 2xh plus h squared plus h in the numerator and h in the denominator. And cancel the h's out. Cancel, cancel, cancel. And we get 2x plus h plus 1. So since h is approaching 0, we substitute h equals 0. And so we get 2x plus 1. And that is the derivative of the function x squared plus x. And we usually denote the derivative as f dash x. Okay. Let's try another example. Let's say find the derivative of the function fx, where fx is equal to 3x squared plus 4x plus 3. So fx is equal to 3x squared plus 4x plus 3. Now we use the formula. The derivative of x equals limit as h equals 0, and then f x plus h minus f of x over h. Okay, let's substitute the values in. F of x plus h is 3 x plus h squared plus 4x plus h plus 3. That will be minus 3x squared plus 4x plus 3 brackets over h. That's a lot of simplifying to do, but we have to do it. Lim h approaches 0. I'll skip some working. That will be 3 times x squared plus 2 times 3, so that's 6. 6xh plus 3h squared plus 4x plus 4h plus 3 minus 3x squared minus 4x minus 3 over h. And now 3x squareds cancel out because one's a positive and one's a negative. The plus 4x and the 4x cancels out. The 3 and the 3 cancels out. And we're left with limit as h approaches 0. That's 6xh plus 3h squared plus 4h over h. Now we can get rid of the denominator by cancelling the h's on top. H. So we get lim as h approaches 0, 6x plus 3h plus 4. Now since h is approaching 0, we just substitute h equals 0. So that thing's gone. And we can say that the derivative of the function fx is 6x plus 4. Now there is an easier way to find the derivative, but you will need to know how to use the first principles, because it usually comes up in your exam. Okay. Now the faster way is to just move the power here, so it's 3 times 2, and then subtract 1 from the power, so that's x, and then plus, that's x to the power of 1, so move that to the front, 4 times 1, and the x goes away, and the constant is 0. So our derivative is 6x plus 4, which is the same as this, but we'll talk about that in another video. Now, last example. Find the derivative fx equals 2x cubed minus 1 by using the first principles. Now let's get straight into it. The derivative of fx equals lim as h approaches 0, f of 2x cubed minus 1 f of x plus h minus f of x over h. Lim as h approaches 0, that will be 2x plus h cubed minus 1 minus 2x cubed minus 1 in brackets. H lim as h approaches 0, that will be 2 times x cubed plus 3x squared h plus 3x h squared plus h cubed. Pascal's triangles become really important when you're doing binomial expansion. So 1, 1, 1, 2, 1, 1, 3, 3, 1. These are the coefficients of your terms. So that's 1, 3, 3, and 1. And you can use Pascal's triangles to easily expand brackets. And that will be negative 2x cubed plus 1. So we get, and minus 1 here. So we get 2x cubed plus 6x squared plus 6x h squared plus 2h cubed minus 1 minus 2x cubed plus 1. So that would be lim h approaching 0 over h. That needs to be over h2. And then lim as h approaches 0 would be, okay, that cancels out with that. 1's cancel out, and we get 6x squared h plus 6xh squared plus 2h to the cube h. We cancel the h in the bottom, cancels out, that cancels out, and then that becomes a 2. So we get lim as h approaches 0, 6x squared plus 6xh plus 2h squared. Now h is approaching 0, so we substitute h equals 0. So this will be 0, that will be 0, and we just get 6x squared. Great. And that's how you find the derivative of a function.